Good afternoon, everyone. Today we're going to evaluate some expressions using fractional exponents, negative exponents, and then some exponent rules to simplify something like this. Okay? So the first one we have negative 16 to the power of negative 3 over 4, and I'll bring attention to the fact that the negative is not inside of a bracket. Okay? That means that the exponent of negative 3/4 is not attached to that negative in front of the 16. Okay? So we're going to treat it as such. So we're going to write negative, and then we'll deal with the 16 to the negative 3/4 separately. The negative at the front is just going to stay there at the front. Okay? So remember, a negative exponent just flips the base. We take the reciprocal of the base. I'll remind you that 16 obviously can be written as 16 over 1. So that negative exponent, all it does, its only responsibility is flipping the base, okay, to its reciprocal. So that means we're going to have negative 1 over 16 to the power of now positive 3 over 4, okay? Next, what does a fractional exponent mean? Well, the numerator is just kind of an exponent. The denominator tells us the root that we need to take of the base. So a denominator of 4, excuse me, a denominator of 4 suggests that we take the fourth root, okay? Take the fourth root, okay? So we can write it like that so you can visualize what this means. It's going to become, we're going to have negative the fourth root of the base 1 over 16. And then we could have the cube, the exponent of 3 inside, or we could have it outside, whatever you deem to be easiest to compute, to kind of deal with. I'm going to leave it outside because this is actually pretty easy to handle just cognitively. We have negative the fourth root of 1 over 16 is the fourth root of 1, which is 1, over the fourth root of 16, which is 2. So we have negative, again, no brackets, negative 1 over 2, still raised to the power of 3, right? You could even put brackets around only the 1 over 2 if you want. So you can kind of see the exponent of 3 being attached to both the numerator and denominator. And now we'll have negative. Again, one of our basic exponent laws says when we have a fraction raised to an exponent, the exponent just hits both parts of that fraction. And so we get negative 1 cubed is 1 over 2 cubed being 8. And so we get negative 1 over 8. Okay? Now, for part B, here we have some exponents being multiplied through raised to another exponent. Now, one of our exponent laws says that whenever we have an exponent raised to an exponent, we can multiply the exponents, and we certainly could apply that here, but you'll see that it's probably easier to simplify the expression inside the bracket and then wait to deal with the exponent 4 at the very end. That's just a matter of preference. I do think it'll be simpler in this case. So, 8 to the power of negative 2 over 3, again, a negative exponent has the only responsibility of flipping the base. I'll remind you that 8 can be written as 8 over 1, and so the negative exponent turns this into 1 over 8 to the power of now positive 2 over 3 times 4 to the power of 3 over 2. The 2 in the denominator means we take the second root, or as we call it, the square root, right? The 4 in the denominator meant we take the fourth root, written as radical fourth root. Here, 2 in the denominator, and so we take the square root, right? So we'll have the square root of 4 cubed, and again, all this to the power of 4. Now we have 1 over 8 to the power of 2 over 3, right? The denominator of 3 suggests that we take the cube root, right? And the 2 in the numerator is just going to act as an exponent of 2 at the end. So we will have the cube root of 1 over 8. You can put this in brackets if you'd like. Square, this to me is the easiest to read off, and so I'll put this cube root inside a bracket and then square, and then we can deal with this stuff. The square root of 4 is obviously just 2, so we have 2 cubed. And again, the exponent of 4 turning outside. Now let's deal with the first part. I'll leave them red. So the cube root of 1 over 8, again, it's just the cube root of the numerator over the cube root of the denominator. So we have the cube root of 1 over the cube root of 8 being 2, and all of that is squared, times 2 to the power of 3 is 8, and again, an exponent of 4 outside. right? I'll bring that over here. Now our expression is going to become, whoopsies, I missed the bracket here. There we go. The best looking bracket, but, right, because we need the big brackets for the power 4, and then the 1/2 is still being squared. So now we have 1/2 squared, which is 1/4, right? 1 squared over 2 squared times 8, all being raised to the power 4. 1/4 times 8 is 8/4, or 8 divided by 4, meaning 2. And so we end up with just a nice 2 to the power 4, 2 times itself, 4 times, is equal to 60. And there's our value. So, fraction exponents just provide us with the information that we need to take whatever root is in the denominator. The numerator just acts as a regular exponent, the same way that you've always dealt with exponents. And feel free to write fractional exponents as radicals. That's often easier to kind of deal with when we're still getting used to them. And then the rest is just being careful with all of our exponential values. So hope this helps. Thanks for watching.